Hi, I'm Richard Overdorf with Agilent Technologies. Today I'm going to talk about real-time spectrum analysis with the mid-range MXA signal analyzer. The MXA is a great fit for wireless. It has the widest bandwidth and the highest performance in its class. Today we're going to do a quick review of what real-time is, and then we're going to look at the MXA identifying and troubleshooting issues in the physical layer of a communication system. The real-time MXA has 160 megahertz of real-time bandwidth. It's upgradable, and it's also a fully featured swept-tuned spectrum analyzer. I also have with me today a MXG X-Series signal generator, and right now we're generating an LTE advanced waveform. Let's get started with some analysis. We are now looking at the MXA displaying this LTE advanced uplink signal in the traditional swept mode. As you can see, this is a little difficult to understand all the elements of this signal. Displays like the spectrogram allow you to see what is taking place over time to understand the spectral environment and detect unexpected events, such as interference. Another approach is to view the waveform in zero span or in the time domain to see how the waveform is turning off and on, but you lose the spectral view. If you are measuring waveforms with short rise times or fairly narrow pulse widths, your bandwidth will be limited by your analyzer's resolution bandwidth filter. In most cases, this is less than 10 megahertz. While these displays are useful, they are missing a large amount of spectral content, which can make it very difficult to detect and troubleshoot problems. In the MXA's real-time mode, we are processing the gap-free time domain samples very fast, almost 300,000 FFTs per second. This allows us to see the entire bandwidth without gaps, so we see all the transient activity and don't miss elements of the signal. The density display uses color coding to show you how frequently a signal is on or off. In this case, how frequently a signal hops around. The display can help you easily identify even the toughest intermittent spurious activity, or even identify interference. Now, with real-time spectrogram, unlike the swept spectrogram, you can see a complete view of the spectral environment. Lowering acquisition time provides greater time resolution and allows you to see how the signal behaves over time, making it much easier to quickly identify and understand if the control channels are on, as well as their sequence. In power versus time, you can see a gap-free time domain waveform. In addition, you can add the spectrogram and frequency displays to the time domain view and analyze the full 160 megahertz of bandwidth, rather than being limited by the bandwidth of the resolution bandwidth filter. In this carrier aggregation signal, the display clearly shows lower level interference. This could be either in band or out of band. Using just the real-time spectrogram, you can identify many signal characteristics without even demodulating the waveform. Next, let's take a look at a wireless LAN signal. Again, as many commercial signals are bursted and most military communication signals are frequency hopping, it can really make it difficult to see and identify problems in the transmission with traditional swept analysis. In real time, we have not only an opportunity to see all the bursted signals, but we also see interference. A common issue is interference between wireless LAN and radar signals. With the real-time MXA, you can see how these signals interact, identify how the wireless LAN signals respond, and measure the transient activity in the real-time spectrogram display. In the power versus time display, we get an idea of what pulse repetition interval the signal is at, while simultaneously viewing the spectrum to see how other signals behave. Finally, let's take a quick look at the frequency hop signal and then dig deeper with some more analysis. If you wanted to understand as much as possible about a signal, a good approach would be to either use triggering or use a recording when triggering is not efficient. Most signal analyzers cannot record signals much greater than a few seconds at wider bandwidths. Fortunately, with the real-time MXA, we can use a frequency and amplitude selective trigger, which can be used to trigger measurements or recordings. This modulated carrier's unique hop sequence is longer than the analyzer's available memory, and hence the frequency match trigger is needed to only record or measure the desired portion of the waveform. You can define and save mask settings to be used later. Importing the mask into 89600 VSA software allows us to do a recording based on the real-time frequency match trigger. This same functionality can be used to understand how the signals behave with interference or to make measurements when spurs or other impairments are present in the spectrum. As you've seen today, the MXA provides the widest real-time bandwidth and the real-time analysis capability to find signals that are 4 times shorter than comparable analyzers. The MXA also provides flexibility needed with variable RBWs to identify a wider range of signals, as well as the total solution needed by adding the 89600 software for deep troubleshooting. In addition, the MXA is a full-featured swept-tuned signal analyzer, best-in-class phase noise, 160 MHz analysis bandwidth for demodulation or analysis with one of many of the X-series measurement applications, such as LTE, wireless LAN, and multi-standard radio. For more information, visit the URLs on the screen, or watch one of our other real-time videos. Or you can also contact your Agilent representative. Upgrade your MXA and have the best mid-range analyzer on the market today. If you need more performance, the PXA is the highest performance X-series analyzer. It has the same user interface as the MXA and is also software upgradable. Thanks for watching.